Section 7.3 is on similar triangles. Now the cool thing about triangles and showing that two triangles are similar to each other is that you don't have to go through all of the steps that we did to show that two polygons are similar to each other. We don't have to show that all the angles are congruent and all the sides are proportional. We actually have some theorems and postulates that can kind of give us a shortcut to that. The first one is the AA similarity postulate. And remember from when we did congruent triangles, we used A for angle and S for side. We're going to do the same thing here for similar triangles. So the AA similarity postulate says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So given triangle ABC and triangle DEF, if angle A is congruent to angle D and angle B is congruent to angle E, then triangle ABC is similar to triangle DEF. So all we have to do is show that two angles of one triangle are congruent to two angles of another triangle. That'll show us that they are similar to each other. The Sss Similarity Theorem uses sides. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if corresponding sides are proportional, so if AB over DE is equal to BC over EF, which is equal to CA over FD, then we can say the triangle ABC is similar to triangle DEF. So all three pairs of sides have to be proportional to each other. And the last one is the Sas Similarity Theorem. Remember we had Sas for congruent triangles, where the congruent angle had to be between two congruent sides. So again, the angle we're talking about has to be between the two sides that we're talking about. So this says if the lengths of two sides of one triangle are proportional to the lengths of the two corresponding sides of another triangle, so two sides of one are proportional to two sides of the other, and the included angles are congruent, so the angles in between are congruent, then the triangles are similar. So there's no way to really mark on a diagram corresponding sides, but I'll just use some color here. So if AB over DE, which is this one right here, is equal to BC over EF, which is this one right here, and we have it already marked, angle B is congruent to angle E, and you'll notice that angle B is the angle that's between the two sides I'm talking about, and E is the angle between the two sides I'm talking about. Then I can say the triangle ABC is similar to triangle DEF. So two pairs of corresponding sides proportional and the angle in between those sides congruent. Then by Sas similarity, we can say that they're similar to each other. Let's take a look at a couple examples here. Determine whether these triangles are similar. If so, write a similarity statement and explain your reasoning. By explain your reasoning, state which one of those theorems or postulates applies. Okay, so here we have a couple triangles, and we have a couple sides that are parallel to each other, which is actually kind of cool. So because these are parallel, well actually let's do the easy one first. I know that angle JLK is congruent to MLN because those are vertical angles. That's kind of nice. That makes it easy. Also, I have parallel lines, and I can look at either one of these as being a transversal. So I can say that angle K is congruent to angle M because I have parallel lines cut by a transversal, MK, and K and M are alternate interior angles. So I have angle K is congruent to angle M, and angle JLK is congruent to angle NML. Oh, I'm sorry. NLM. Okay, so since I have two angles congruent to each other, yes, they're similar. Yes, in fact, let's go ahead and name them. Triangle JKL is similar to triangle. Now I have to name it the same way. So to name JKL, I went from the angle that had no mark in it to two pink arcs to one pink arc. So I have to do the same thing over here. That's going to be NML. NML. by the AA similarity. Because two angles of one triangle are congruent to two angles of another triangle, therefore I can say the two triangles are similar. Example number 2 here, I don't have any specific information about angles, but I do know that those two are going to be congruent to each other because they're vertical angles, but I do have information about the sides. So let's see, so which sides would probably correspond to each other? Most likely 6 and 9. So let's do, is 9 over 6 equal to, now remember usually these things are kind of flipped a little bit. Or are they in this case? Well, let's try it. Let's try 7.5 over 5. And actually the reason I did 5 instead of 4 is I don't know that the 9 is parallel to the 6, that AB is parallel to DE. If they were, then it would probably have to be flipped. And is that congruent to 6 over 4? Okay. Now if I grab my calculator and do each one of those divisions, I get that 1.5, and that's a 1.5, and that is also a 1.5. So yes, the corresponding sides are proportional. Corresponding sides are proportional. I'll go ahead and write that out. So by SSS triangle, let's do ABC, is similar to, and since I did ABC, DEC by SSS. And our third example here is kind of like a triangle within a triangle. So I have triangle SQU and triangle SRT. So I need to say, are those two congruent to each other? Well, the first thing I know is that angle S is a part of each triangle, and so angle S is actually congruent to itself. Notice that is an angle in triangle SRT, and it's also an angle in triangle SQU. Now I need to ask myself, is the left side of the small triangle compared to the left side of the big triangle? So in other words, is SR, so the short side here, over SQ, is that equal to the short side on the right, ST, over the long side on the right, SU? In other words, is the left side of the small triangle over the left side of the big triangle equal to the right side of the small triangle over the right side of the big triangle? So is 10 over, now this is tricky, how long is SQ? You might just want to put 15 because it's sitting there, but SQ is actually 25. Is that equal to ST, which is 12, over the whole side, not just 18, but the whole side, which is 30. And actually in your calculator, if you to reduce these, this is going to, oh, hold on. My notes are a little bit different. Let me do this in the calculator here. 10 divided by 25. That's going to give me 2/5. And 12 divided by 30 also gives me 2/5. So yes, the corresponding sides are proportional to each other. So we have one angle congruent, okay, and then we have two corresponding sides proportional. And notice that the angle is between the two corresponding sides, so by the SAS similarity, we have triangle SRT is similar to triangle SQU. SRT, SQU. Order matters. Okay, let's use that to help us find some values here. So I need to find RQ and QT. So first thing I need to do is figure out, are these triangles similar to each other? Well, I know that those guys are congruent to each other. And because I have parallel lines, remember, anytime you see parallel lines, think parallel lines cut by a transversal, and a lot of times it's going to be alternate interiors. So angle T is going to be congruent to angle R. Okay, so I do know that I have two angles of this triangle congruent to two angles of that triangle, so I know that these two triangles are congruent to each, I'm sorry, these two triangles are similar to each other, and since they're similar, their corresponding sides are going to be proportional. Let's just go ahead and write that. So triangle QUT is similar to triangle QSR by the AA similarity. Okay. Now this, actually writing out this similarity statement will help me to set up the proportion with my other sides. Okay. Since 10 is between two arcs and no arc, and 4 is between two arcs and no arc, I can do 10 over 4 is equal to, and 2x plus 10 is between one pink arc and two pink arcs, and x plus 3 is this in the same position over here. I can do 2x plus 10 over x plus 3. Now I have a simple proportion, and I can just solve that. So 10 times x plus 3 equals 4 times 2x plus 10. 10x plus 30 equals 8x plus 40. 2x equals 10, or x equals 5. I'm not done because I have to find RQ and QT. So RQ, plugging in 5, that's going to give me an 8, and QT, plugging in 5, is going to give me 20. So what we did was we showed that these two triangles were similar to each other by AA similarity. Since the two triangles are similar, then their corresponding sides are going to be proportional, and we use that to find the value of x and ultimately the lengths of RQ and QT. And our last example here says a cell phone tower casts a 100-foot shadow. At the same time, a 4-foot 6-inch post casts a 3-foot 4-inch shadow. How tall is the tower? Let's go ahead and draw a picture here. So this is going to be my cell phone tower, okay, and I don't know how tall it is. I'm going to call that x feet. But the shadow it casts is 100 feet. So, you know, imagine the sun is over here and the sun's shining this way, and the tower casts this shadow. Okay, at the same time, so in other words, the sun hasn't moved, a post that is 4 feet 6 inches casts a shadow that is 3 feet 4 inches. Okay, so here's the cell phone tower and its shadow. Here's the post and its shadow, and basically what we have, because we know that the post and the cell phone tower are going to be perpendicular to the ground, basically we're going to have two similar triangles here. So we need to know how tall is the tower. So let's set up a proportion. I can say, actually the way I think I'm going to do this is I'm going to say the object over its shadow. Okay, so the height of the tower over its shadow is equal to, now notice I have just feet on my cell phone tower, but I have feet and inches on my post. So a 4-foot 6-inch post, 6 inches is a half a foot. That's actually 4.5 feet tall. My post is 4.5 feet because 6 inches is a half a foot. And its shadow is 3 feet 4 inches. 4 inches is 1/3 of a foot. So that's 3 1/3. Okay, now I have a proportion I can solve. So 3 1/3 times x equals 100. Let's do 100 times 4.5. Now be careful here. Do not turn this into 3.3. It's 3.3 repeating. I'm going to leave it, I know you don't like this, but I'm going to leave it as a fraction. So that's actually 10/3 x is equal to 100 times 4.5 is actually 450. Solving for x, x is equal to 135 feet. So a 135-foot cell phone tower casts a 100-foot shadow when a 4.5-foot post casts a 3 1/3 foot long shadow.